Okay, hi class. Find the probability that a randomly chosen US adult male is between 76.4 and 79.1 in height. So the way we're going to be finding probabilities is we're going to be, well, of things that are normally distributed, is we're going to be finding the area under the normal curve in that interval. Oh, so it says find the probability that a randomly chosen US adult is between 76.4 and 79.1. So we need to find the area, this area. This area right here under the curve. And luckily enough, they don't actually they don't actually have us actually calculate this by hand, but we're going to use our calculator. So but the biggest thing that we have to be able to know how to do is describe the interval in which we want to find the area under the curve. So in this case, we want to describe, I want you to find the area under the curve between 76.4 and 79.1. So let's, and to get that correct, you kind of really have to know how to write interval notation and understand intervals. So I'm going to talk to you about writing in interval notation and also, how that relates to going straight into the calculator to find your answers. So let's just review a few basic questions and just reviewing intervals and interval notation. First of all, let's do a simple one. Let's just we're going to write interval notation for this simple one. Find or highlight. We're really going to write the interval for all numbers between 6 and 10. So this is simple. Like what we're going to do is we just circle. So the lower number is 6. So we kind of circle that one. And the upper number is 10. So we circle that one. And then we highlight all the numbers in between to represent. This is how I would graph, I represent the answer graphically by drawing it. That's one way to describe to somebody what the interval is, by just drawing it for them, right? Okay, so the second way to do it would be to write in interval notation the numbers between 6 and 10. So, and the way this goes is you put parentheses, or I'll go into this. Technically, if you include the 6, so you mean like including 6 and including 10, so we would also highlight those in yellow too, then you would want to use a square bracket. So just so that I'm properly teaching you interval notation, technically you'd want to use a square bracket if it included 6 and 10. And if it did not include 6, so like all the numbers between 6 and 10, but not including 6 and 10, so like including like 5, I guess, including 6.1111 or 6.0001, numbers real close to 6, but not actually 6 itself, then you would use parentheses. Okay, I'm not going to worry about that. I'm not going to stress about that because it's not important to us, but so I'm teaching you correctly. So we're just going to say that always it just doesn't include 6 and 10. We'll just say it does not include 6 and 10, so that I can just use this interval notation. So so in interval notation, I would put it in parentheses, and then the smaller number needs to go first. So and then I just go comma, larger number. So this is my way whenever they're saying in the interval 6 to 6, parentheses, 6 comma 10 parentheses, when they say that in a sentence, they mean all numbers between 6 and 10, not including 6 and 10. So that's like math shorthand, right? So, but there's one caveat that you have to make sure that this is the lower number is first in parentheses, and that the second number is the larger number is second. Okay, so let's go for just do another example, and mathematically, just in case you were saying, okay, I'm not gonna mention anything else. Okay. Just so you know, mathematically, it would have looked like this. It would have looked like you put the X, and whenever you have the word between, you just put the X in between, and then you put the lower number and you put the higher number, and it would look like this. Because I'm just saying that because you might see, so it might be written the probability of the X value being between 6 and 10. So you have to be aware that you might see that in notation as well. Okay. And they're just asking what's the probability of the value of the random variable being between 6 and 10, right? So you'll know what they mean when they say that. Okay. What if they say all values less than 7? So let's just do, let's do less than 1. So mathematically, it looks like this, just a mathematical sentence, X less than 1. And I make sure that the alligator's mouth, the alligator's mouth right here, is facing toward the larger number. So that's how I remember it. And some people just say, oh, you're pointing, that the small pointy edge of the arrow is next to the small number, and the wide mouth is opening toward the bigger number, right? Okay. So that's X is less than 1. So the way we would write that, and if I wanted to show people what I'm talking about on a graph, I would communicate that by putting a 0 or a circle around 1 on the number line, and then I would just highlight all the numbers that are less than. And if it helps you, I think smaller than. So I think what is smaller than 1? 0 is smaller than 1. If I what's worse than having only $1 in the account? Having debt and owing people money, right? Having $0 in the bank account. So that's what the solution looks like if you graph it. Okay, if you want to write it in interval notation, which is really what we want to do, it gets a little bit weird. In interval notation, I do want to notice that this number line is really going on forever. We want all numbers, not just the ones that we have on our number line, we want all numbers that are less than 1. So that actually goes to negative infinity, right? If I keep what happens after negative 10, negative 11, then what happens after negative 11, negative 12, it goes on and on and on until you get to a really, really large negative number, which is negative infinity, okay? And then all the way to the positive value of 1. So in interval notation, this one, it's going to look like this. In parentheses, I'm going to put my smaller number in the interval. It's also the number on the number line further to the left, right? So I'm trying to describe this yellow region of numbers, right? So, and then I put my larger number. And I think where does this, and these numbers that I put in parentheses are where the shading, this yellow shading starts and stops. So I'm reading it from left to right, like I'm reading a page. So like it starts at negative infinity, the shading is starting at negative infinity and going all the way and stopping at 1. I'm reading it from left to right like it's a page. So the smaller number on this interval is the negative infinity. And the larger number on the interval, where it stops, the biggest number that it could be is 1. So that's what the notation looks like for when in interval notation, if we were trying to explain to somebody all numbers, like between negative infinity and 1, then you would write it like this: comma, parenthesis, negative infinity, parenthesis, or comma, 1 in parentheses. Okay. Okay, let's do one more. If they're talking about all numbers like greater than 8, right? Let's write that, and it's a math sentence. It's x and 8. I know that there's those, when they say all numbers greater than 8, let me write that sentence out as it's, because there's a, oh my gosh, this is hard because we're having to go from an English sentence to a mathematical sentence to interval notation to drawing it, and we have to understand all of them at the same time. So it's hard, it's a lot. Okay, so all numbers greater than 8. I'm just going to say write or express all numbers greater than 8. Okay, so maybe so what we want to do is we know that there's, when they say all numbers, we translate that as an x, right? An x. And when we say 8, then we put an 8 down. And then when they say, now we have to decide, we know it's an inequality symbol, like it's a mouth, it's an alligator mouth looking thing. But we have to decide, does it face the x or does it face the 8? So let's just try something, because there's only 2 directions that I could only go this way or that way, right? There's only 2 directions. So if I draw it this way, is this expressing all numbers greater than 8? So if all numbers are greater than 8, where the x is, that value has to be greater than 8. Is the all numbers where the variable x is that bigger than 8? Is that what this sentence is showing? No, it's not, because the inequality, the alligator's mouth, should be facing the larger number. And so we want to say the x is bigger than 8. So that's what it's going to look like in mathematically. I translate the word all numbers into the value x, and then I translate the 8 into the 8, and then I just know to put the inequality in between, right? Okay, so that's what it looks like mathematically. Now let's look like what it looks like as a drawing. As a drawing, there's only one number here. So I go to the 8 and I circle 8. Then it says the values, we want all numbers greater than 8. So greater than 8 is, you have to kind of think about this. There's only 2 sides. So this value 8 is splitting this number line in 2 places. You have side number 1, the left side, and the right side. And we have to shade one of those sides. Where are the numbers bigger than 8, greater than 8? Sometimes you have to ask yourself, is it where the 7 and 6 and 5 are those numbers greater than 8? Okay, no, they're not, right? They're less than 8. So is the 9 and the 10 greater than 8? Oh yes, the 9, 10 are greater than 8. So that's why we're going to shade this side. And remember that, like, we're just not shading the answer here. When we want all numbers greater than 8, it's not just 9 and 10. It's assumed that this number line and all number lines go on forever, right? Unless I guess, the particular problem they say only, but they specify otherwise, right? Otherwise, we assume that goes on forever. So where is this shading, this yellow shading, going to stop? We're going to keep bigger and bigger. We're going to be 10,000, 10 million. We're going to get bigger and bigger and bigger. So to positive infinity. And this time, because they're positive numbers, it's positive infinity. So the way to write this in interval notation is you write the smaller number or we can call this number the lower bound of the interval because it's bounding. Something bound is a boundary. It's a bound. You don't go past that. The highlighting doesn't go past it. So the smaller number or the lower bound, because that's what your calculator calls this value, the lower bound, it is the 8. I go parenthesis 8, comma, and then the upper bound, the larger number on this interval, is, or also known as the upper bound number, and I could have used this notation on a previous problem, but whatever, is positive infinity. And that's what the interval notation looks like. Okay, so they could write it as in your problem. You may see they may say find the probability of all values greater than 8. You might see it in English writing. You might see it written as a graph, probably not, but it's important to kind of see it on the graph and know exactly what numbers you're talking about. They might write it as a mathematical sentence, or they might give it to you. I doubt it, but it's important for whatever, if they give it to you as a mathematical sentence or a graph or numbers, it's important for you to write it in this interval notation correctly, because their calculator is going to be asking you, what is the lower bound? What is the upper bound? If you can't write it in that, find that out, then you're going to get the problem wrong, right? Okay. So let's see an actual example. In the country of United States of Heightlandia, the height measurements of 10-year-old children are approximately normally distributed with a mean of 54.6 and standard deviation of 8.4. What is the probability that a randomly chosen child, 10-year-old child, is between 51 and 53 inches? So they want us to find, like I said, to find the probability, we find the area under, and they would have to tell you that they tell you it's normally distributed. So we can draw the normal curve. And then to find the probability, we're going to have to find the area under the curve between 51 and 53 inches. We're going to actually be finding the area under the curve, but of importance to us, we have to describe to the calculator what the values on the x-axis, the interval in which we're going to be shading under the curve. So let's draw just the interval on the x-axis, just the x-axis, so that you can tell the calculator correctly where you want to find under the curve. So we just want to find between 51 and 53. So it's going to look like 0 at 51, 0 at 53, and all the values between it. That's what it looks like on the number line. Then if we want to write it as an interval notation, one more thing, this would look like you put an X in the middle, you put 51 and 55, 53, and then you put 2 less than signs in between. And I just have done this so many times, I just remember, I know what that looks like. So that is the mathematical sentence. They may ask you probability of X between 51 and 53, or they made sure, and here's the drawing of what they really mean. And we could put 52 would be in that interval, right? And then now let's write the interval notation. So like I said, you take the smaller number on the interval, like if I'm reading it from left to right, like where the shading starts, So it's starting at 51, and you put parentheses, and this is a smaller number, and it's also the lower, it's called the lower bound. Is the 51, comma 53 is the larger number, and it's the upper bound. I'm just going to go with upper bound. Okay. All right. How we would enter this into our calculator to find our final answer would be, we just have one more thing. We have to tell them it's a normal distribution. So we do normal CDF. And we have to tell it what the mean is. So we tell, it says the mean here was, the mean of the distribution was 54.6, and the standard deviation, we have to tell the standard deviation. So the mean was 54.6. The standard deviation is 8.4. And then we just have to enter now the lower bound, and the upper bound of where we need to find the area under which curve. And so all we do is at the 51 and the 53. Okay. And that would be the probability P of X being between 51 and 53. That's the probability that, that we get a randomly selected child to be between 51 and 53 inches. Okay. All right. Now let's do the second one. What is the probability that a randomly chosen 10-year-old child is less than 48 inches? So first, to find that probability, we need to find the area under the curve, but we need to tell it where under the curve do you want to be finding the area. And we want to find the area under the curve for all the values that are less than 48. So I graph, we said the middle was 54. So I get a chance to know where 48 might be along this x-axis. So say this is 48. Then the area under the curve that I'm really looking for is this. But in order to find that area under the curve, I need to input the right, interval along the x-axis, because all I need to do is tell it along the x-axis where I need to find the area, right? I just need to give it that interval along the x-axis. So I draw the area under what is less than 48. So that mathematically is a mathematical sentence. I know I write an X and a 48. And then I'm going to put the small part of the arrow closer to the smaller number. So if we want the values to be less than 48, then this X needs to be less than 48. And the arrow, the smaller part of the arrow is on next to the smaller number, the X, which is X is supposed to be smaller, less than 48. Okay. So then I graph the 48 on the number line. And then it says, where are the numbers less than 48? Well, less than number lines, you have to understand, they're increasing from left to right. So, so this would be 47, and this would be 46, and this would be going on. And then this would be, 50, 49, 50 going on, right? Okay. So this, if we go for 46 and we keep getting smaller, 45, we're going to eventually get to 0. And then after that, we're going to eventually get to negative infinity. And if we go the other direction, we're going to eventually get, 50, 60, 70, 80, 100, bigger, we're getting to bigger positive numbers on that side. So I'm going to draw it, and we circle where the 48 is, and then we shade values that are less than 48. So we have to think, what is less than 48? What is less than means smaller than, right? So it is 47, and this side, 46, all of this, okay? Well, now I need to write it in interval notation. And I read it from left to right. What is the smallest value that is being shaded? And where is the shading really starting? And it's at negative infinity. So I write in parentheses, negative infinity, comma, where's the shading stop? It's going from reading it from left to right, it is 48. Okay, so this is our lower bound. This is our upper bound. Okay. And how we would enter into our calculator is we would write it like this: the probability of the variable being less than 48. Okay, that's shorthand for probability of the variable being less than 48 is equal to the normal CDF and I'm going to enter in the same mean and standard deviation that we saw a minute ago above, because this is the same problem. And it's still going, is still dealing with the heights of the kids, and the mean is 54.6 and the standard deviation is still 8.4. So we could still put that in for this problem. But now we put the lower bound in, and that's, so this is where it gets hard. The calculator will not understand negative infinity in those calculators. I think if you're using class calculator, you can put negative infinity. But what normally happens is you put a very large negative number. And 1e to the 99 means -1 times 10 to the 99th power. So it's a very extreme, it's -1 with 99 zeros after it. So it's a very extremely large number. However, it's hard for a lot of students to grasp even what that number is. So if you could put -1e to 99, or you could probably just get away with like negative 100 is probably a big enough number. So you could either do that, but we're trying to put negative infinity. The lower bound is -1 but like I said, sometimes we can't put that into the calculator always because it doesn't make any sense to the calculator. So, but what we could do is just put a really large negative number. You could either put -1e to the 99. And be careful because on your calculator, let me show you on the calculator where you would do E99. So I would go see that EE. So you don't want the E just by itself. There's a green E, a single E. What you actually want is EE. That's the shorthand for times 10 to the power of this, so you go second. So you would put into your calculator the -1, and you want to use the negative sign that's on the bottom here. And then that's by the enter key, not the subtraction sign. You'd want to use the negative sign that's below the 3. And then you click 1. So you -1, you enter -1, and then second, and then comma. It's right above the 7. And then you could put the 99 in. Okay, that's how you put that -1 EE to the 99. I don't know why they don't, sometimes they just put -1 E to 99, but they actually mean EE. I'm not sure that's just the calculator shortcut for like times 10 to the, because it means -1. This means -1 times 10 to the 99th power. But that EE means times 10. to the power of that. Yeah. Okay. So if you don't like using that scientific notation, like I said, instead of entering negative infinity, because your true lower bound should be negative infinity, and this is our lower bound we're entering into our calculator. But like I said, some calculators, not all, will accept, like the negative infinity. So you could put a really large negative number, like negative 100,000, or you could put negative 1e99. And then the upper bound is where is right here, upper bound. So that's the 48. And then I would close parentheses, and that's how I would calculate it on the calculator. All right, one more problem, and then we're done. So we're doing the same thing, the same situation where you have the heights of the male 10-year-old children are approximately normally distributed with 54.6 inches and 8.4 inches as a standard deviation. I probably said that wrong, sorry. But anyways, that's the basic information for all these questions. And then they say, what is the probability that a randomly chosen 10-year-old child is more than 62 inches? So how do I write that mathematically, or shorthand mathematically? Is P X greater, so the alligator's mouth is pointing toward the X, because we want the value to be more than 62. And notice how that's what it would look like mathematically. To draw it, well, and what we really want to find is we want to find the area under the normal curve that is bigger than 62. Like I said, the 54, they said, because the mean is where the peak of this is. So the 54 is in the middle, 54.6. But then, so the 62, since if we're going from left to right, the numbers are increasing. So 62 is going to be to the right of that. Then the area that we want to find is the area under this normal curve to the right of 62. Now, our job, we don't have to really calculate that area. I mean, we do. We're going to make our calculator do all the hard work. But our biggest job is to correctly describe this area that we want to find, the area and the curve that we want to find under the curve on the x-axis. So let's describe that. We draw it. It's what are the values larger than 62? So I draw 62 and I circle it. That's a crucial value. And where are the numbers bigger than 62? And so, like I said, if we go from left to right, we're increasing. So it's 63 over here. It's 64 and 65 and so on. And it's going to go on and on and on, right, to positive infinity. Then you have the numbers on the other side are 61, 60, 59, and then it's going to go on and on and on. It's going to go 0 eventually once you get 59. And then it's going to start getting negative numbers, and then all the way to negative infinity, right? So where are the numbers bigger than 62? They're over here. 63, 64, 65, all the way to, it's important, the upper bound is positive infinity. So to write that in interval notation, I write parenthesis 62, parenthesis positive infinity. And so the lower bound is 62. Upper bound is positive infinity. So how are we going to do that on our calculator? So I'm just going to copy and paste from above. It's all this, well, never mind. I'll just write it out. X is greater than 62. The probability that the variable will be greater than 62 is equal to the normal CDF and I enter the same mean and standard deviation that I did above. 54 and 80.4. And the only thing that I really have to make sure I get correct here is I have to correctly enter the lower bound 62 and the upper bound, which is, okay, the upper bound should really be positive infinity, right? But like we mentioned above, the calculators don't like infinity. So you could put positive 100,000. That's one way. I mean, the real value we want for the upper bound, because this is the lower bound. This is the upper bound. But like I said, the calculator doesn't understand positive infinity, so you could put positive 100, or if you want, positive e to 99, positive 1 e to 99. So you could put either positive 100,000 or positive 1 e 99, either one. But that's how you're doing on a calculator. The common mistake that students make a lot is they switch the upper and lower bounds. So they accidentally write, 100,000 and then 62 seconds. And the calculator's not going to like that. Well, I think it gives you an answer, but like it gives you like the wrong answer. But the other mistake that students make is they put negative infinity instead of positive infinity, or positive infinity instead of negative infinity. So make sure you don't make those mistakes. All right. Okay. I hope you found this very valuable. Have a great day. Bye.